Hello everyone, welcome to Try Rights, the new era of learning. Myself, Rafiq. So let's move to the topic. Uh, in machine learning, we are learning a nice and good topic today. Yesterday we discussed about decision tree, right? So now we are discussing about random forest algorithm in machine learning. Okay. So in simple states, random forest is a machine learning algorithm that uses many decision trees to make better predictions. Each tree looks at different random parts of the data and the result are combined by voting for classification and averaging for regression. This helps you improving accuracy and reducing errors. So the definition may be ununderstandable. So let in my words, I will explain what random forest will helps in machine learning, how the process will continue most, okay, how the process will run in machine learning, okay, in classification way, okay. So random forest in simple explanation, I will explain you. So if you are, imagine you are asking a group of friends to help you make a decision, like what movie to watch. Each friend gives you a suggestion, right? And you go to with the majority choice. So that's the idea behind the random forest. Okay. So many of the questions for firstly, what is random forest? So random forest is nothing but random forest is a machine learning algorithm used for classifications like predicting if an email is spam or not, and for regression like predicting house prices, land prices, and stock market price. Okay, it was to be combining many decisions, right? It is a combine of many decisions, multiple decisions, not just one. It's of many can make more accurate and reliable predictions. Okay, so simple example between random forest and decision making. So in decision making statement, we only follow the one structured tree, only once or one of the flow, the data structure. Sorry, one of the flow of decision making structure we follow. Okay, only one tree we have. In random forest, we have multiple trees based on decisions to make predictions. Okay, here we deal the data with multiple trees, like means multiple data. Take the data set one, data set two, data set three. Like that, we have multiple trees. We want to deal with the trees. Okay, so you have the doubts how it works. How how does it works? Okay, it builds multiple decision trees, like asking multiple expectations. Each tree is built in using random samples of the data. For classification, each tree gives a vote. The class label with the most votes win. Okay. In classification, most of the cases, the majority of the tree will win. Majority of the decision will win. Okay. I will example in simple example too. So for regression, it takes average of the tree predictions. Okay. Why random? You have the question why random? It picks random rows for the data sets. It allows pick on the random subset of the future column for each tree. The randomness helps reduce overfitting when a model memorizes the data instead of learning from it. So let's take an example. A real life example we take as imagine you are trying to predict if your customer will buy a product. Okay, and a single decision tree might say yes or no. Okay, in decision tree we're comparing for random tree and decision tree here. Okay, if you're imagine you're predicting a customer product. Okay, if single tree decision based, it says only yes or no, either yes either neither no. Okay, only one option we have. But in random forest we consult many trees based on the different decisions, different predictions, parts of the data, and go with a majority. Whose majority is high, then we consider our balanced decision, right? In this, we have advantages of working well with the large and complex data sets, handling missing values, and reduce overfitting, gives better accuracy. Okay, so one of the most disadvantages is using more memory. It is not a big issue for us. So this like random forest will work. We have to train model like this different decisions we have to take, and after that we have to check the which decision has a majority, and that we can predict the output. Okay. Now it's handle missing data, simple features, work well with being complex data, use it for different tasks. So here we can see single decision tree gives only yes or no, only in decision. Okay. In random forest, it takes multiple decisions, and after the to overall the multiple decisions, it's predict a majority decision and it takes a finalize a majority decision. Okay. Okay, let's check into the example. Let's take the let's I have an example to you. Let's a boy said I can buy a new iPhone. Let us say, can I buy a new iPhone? He was asking to her friends, asking to his friends, okay, iPhone 16 Pro you want to buy, okay. A friend once said, if you have money, you can buy it. Yeah, it's good. It's he give you a green tick. He give you a check for S. You can buy it if you have money. You can buy it. And friend two said, no, it's I think better Apple 16 Pro. It's better than Samsung. Like second friend said like that. You want to buy Samsung Ultra, not buy instead of iPhone. So he rejected the decision. Okay, now friend 3 analyzed the data and he knows about the phone's features and what are the profits of the phone benefits and most or overall the features about cameras and RAM and working security. So he simply says, okay, you can go with the iPhone. It is better. It is a better choice. We agreed. So here we check majority decisions. Who said a friend one and friend three or has green check. He gives S with he may agree with the decisions of buying a iPhone. Friend two is disagreed. Here we have majority of two agreements and two disagreements, right? So in this case, random forest will work on the majority of the voting. Right? The system works on the voting, majority of voting. So it predict both majority votes of green tech. The final decision will be yes, you can buy the iPhone. So here the explanation of the code, and we want to predict like the data like this heat map. So further we need to install Jupyter. I hope you all install the Jupyter. Let's open the Jupyter notebook. So I'm saying that random forest equal to many decision tree working together. Okay, 1%. So your prediction is stronger than smarter. So here, okay, it is opened. Now open. So from here, now we will take the code. So here instead of this, I'm adding a prediction. Oh, okay. I take a data of load data. Okay. From sklearn dataset, I will import the load datasets because load data is a many big amount of numbers. It deals with numerical numbers. I want to take target of those numbers and I want to make the addition on this number. So in this case, I want to create a random forest classification tree. Okay. So first we need to import pandas as we all know. After that we need to import load data from sklearn, sklearn from data sets, import load digits. Okay, we're importing load digits from here, and now run the code. Okay, from we imported the pandas has and load digits from the sklearn. Now I want to check the what kind of digits have in the load data. Okay, load digits. So for that I use DRI. We know about the DRI function. Mostly we use to describe the function, or it may be called as dictionary of the function. Yes, okay. Now see I have discrete data, future names, frame, images, target names, right? I have the data. So I can see DRS by target, what target I has. I can see like this or like this target. So target is not mentioned. So name target. So I didn't define any target. Okay. So let us define the target for it. I did not assign the target for the data. So first I want to assign the target. For that, importing math for now import the matplotlib matplotlib inline. So for that import matplotlib.py class plt plt dot gray. So usually I printing a matrix form. Okay, the digits which I inside which I enter the input has load digits. So I am printing that load digits. Okay, it may be in the structure of zero or one. Okay, 0, 1, 2, 9. It may be in a matrix form. A bar graph will be present. Nothing. A picture will be present in that the pixel was broken. So from that we can see our identify. The machine can easily identify the number for I in range of digits. What I want to show in image now. So I take as images for I. Okay. Now here I am doing the plot for it. PLT math show. Math show is nothing but mathematical show. It is nothing but it is a matrix show. It is not a mathematical show. Simply some members think like the math show is nothing but the mathematical show. No, not that. It is a matrix show. Okay. Now for matrix show, I'm importing images, right? Oh, wait. Importing images. From here, instead of I in the range, I want to mention range, right? Okay. I am doing compression code. It is okay. I have habited for that. So sorry for that. Oh, okay, I want to print up to 4. Here I want to print it again. Okay, no. So now run the data. Let us see how the code is correct or not. So PNT gray was wrong. So okay. GRA, right. Okay, now see the matrix successfully. So this is 0, this is 1, this is 2, this is 3. So here I entered 4. So matrix is read up to index space. Okay, 0, 1, 2, 3. Right. I entered 4 means it gives a 3. If I enter here 5, it gives up to 4. See, 4. It is a matrix space. Okay. Now the main data. Now I want to enter this all data. So we have we have into 64 columns. So like that we have the 64 like this and for 64 like this, I think so. So I want to print the all data, load data set. I want to take the data, right? Like I'm saying that in pandas in data frame we want to assign the digits load. Okay. Now take pd dot data frame. Okay, from data frame. Now we need to assign the digits load. Okay, from instant of your importing some data, we take the import data. Okay, from load digits. So from the load digits, I enter df. Okay, from a df dot head. Okay, now see how many data we have. So see here we can see the data 63 months 64 bit. Okay, 64 columns, 5 rows. Okay, from this all data we want to create the heat map like that. So which decision is correct and which is wrong. So for that I am assigning the target column here. Target is for to define that to assign the target. We deals with target columns in most of the machine learning because we when we assign the target to the model, then based on the target we design the model. Okay, we enter target and we remove the target, and after that for the target we assign the values to the x and y. Okay, I create a target now. Check once df from 0 to I have to check. Okay, let's take 12. It's a random number. Let, let's check the data. So see, I can check the F header. So I taking the data up to 12. Okay. Okay, 64. Here 64. Here 64 has row 64, column 64. I just take the row has up to 12. Okay. So target 0, 1, 2, 0, 1, 5, 6. See the numbers up to 9 is taking. And after that, 10 again is starting from 1. Okay. Now, so now print the data like x equal to, okay, now x and y. I want to print the data of x and y. Df dot, I want to drop. I am dropping the data. I am assigning the value to the x. Okay. I'm dropping the values. Okay. Target dot, okay, target dot, or no, sorry, access. Okay. Sometimes we get confusing while coding. Be constant on the coding. So columns from access, I am dropping to here. What I am doing for the target column, I drop this target column and I assign the drop to target column to x. After that, I take the values of those column and assign those to y. Okay, dropping, and from here I want to assign df dot. But in backup, the value should remains on the previous value. Okay, here already I assigned value here. This will remains constantly. Here I removing for x. Okay, for y I am again giving the value, and for y I am giving the same value f dot target. So we can see the target column is, the target column is successfully done, x and y. Now we want to import sklearn to test and train the data. We all know about test and train data. So it is nothing more in this concept. We most of use k-fold. K-fold technique like test and train the data. Here from the sklearn model selection, I want to select the model. From model selection, I importing train and test, train, test and split. Okay. So this is our data train test bit. It is a concept. Most of this code will use in machine learning in model building. So when you are building a model, when we are building or we are creating a model, so we want to train and test the model. Okay. So we use this most of this train and split SK model and model selection. We concept in up to end of the topic. Okay. Now I take x train, x test. Okay. Y train, y test. Okay, equal to, I'm assigning these values to try and test split. Okay, try and test split. From here I am giving the values to for x, for y, for I'm assigning the test size value. Okay, here test size value I'm assigning it as 20%. Okay, it is most important to assign the value because depends on the value, the percentage, it gives the accuracy rate of the model. Okay, if I assigning 0.2, I already discussed about the previous class. If I'm assigning 0.2, it nothing but 0.2 is nothing but 2%. It is a 20%. The model when we predict 1, it is 100%. When it is 0.5, it means 50%. When it is 0.05, then it is 5%. Okay, now it I am assigning 20%. Okay, the model, okay, default model will occur. Now I want to now the main step. I'm creating the model. Okay, from sklearn, we had a function called assemble. Assemble, from assemble, I'm importing model. What model? Random forest classification or classifier, right? Random figure classifier. Okay, I'm importing this model. From this model, I am creating a model like this. So from this, I am taking a variable called model and I am assigning the random force here. And from this I assigning a value called assemble. Assemble, no. I'm creating a value and assigning. No, assemble is model. So I want to take here like eliminator. So I want to eliminate the right 20% equal to. So I want to take n equal to right variable name as eliminator. I want to take estimator. So we take estimator. Okay, estimator equal to 20. Okay, from here model dot 50. Model dot fit is a train function. So here we take the data of here we want to train the first in model fit is used for train the data. Okay, for x and y, train the concept. After that we want to check the score of the model. Now the model was completely built. Let us hope no errors will occur. Yeah, our program is successfully completed. We can see here the random forest classification spread 20 is created here. Now from this I want to check my model score once. We are how much score I gain from my model when I'm creating the function. So for that I assign x test and y test. So it's obviously it's doing 95%. Oh, it's great. I created a model and I get a value of 95 score. Okay, I get a 95 percentage on the model creation. It's great. Now the main step. We have a model of random forest. From the random forest, we want to predict the data. Now we can easily predict the data. Now predict the data. Creating y predicting y equal to giving the predicting. So I want predicting some data like predict predict for x test. Okay, on the predicting the x test, I'm assigning y to prediction. Y prediction now. From that we can see the prediction here. From here I creating another model like assembling the matrix. Okay, from matrix I'm assigning sklearn. I'm importing sklearn. From matrix I'm predicting. So we are dealing with the data, right? So I want to predict the matrix now. Matrices I want to import the confusion matrix. Okay, okay. From matrices I am importing confusion matrix to draw a graph. Okay, from confusion matrix I am giving y test here, and after I am assigning y prediction to where I predict. Okay, right, y predicted. I'm assigning y predicted. Okay, from here, okay, confusion matrix. No? So we can take CM confusion matrix as a variable. Now I am printing the CM. We can see the how many. We can see the 64 bit of array. So cannot learn SQL and compare. So it is nothing. It is a spelling mistake right in this. Sklearn from dot matrix. Okay, it's right. Sklearn dot. Sometimes it happens when we're entering the wrong. Even it's little bit of space also it can take the input as error. Okay, fun. I enter the spelling mistake here. Okay. Oh, still it's giving confusion. Confuse. I'm running from here. Okay, I run from here. Still it's showing confusion matrix. I'm change. Okay. Here I didn't change. Right. Sorry. Okay. See now happily my data is created. See. Oh, see 36, 37. So these are my prediction data for x and y. Here I get the truth and actual value, but it's not proper visualization. For the better visualization, we take Seaborn for better prediction. for better visualization. Okay, from that I am taking again matplotlib inline. Okay, here import matplotlib.py plot as gld. From after that I want to import Seaborn. Sn. Okay. From here, I want to plot the figure, right? Plot the figure and figure size as I mentioned. Okay, we'll just take 10 7, right? Okay, now equal to 10 7. I take 10, 7. Okay, from here I am predicting again 10 comma 7. Okay, now I want to close that. So, okay, right now it's fine. So, from SN heat map, it is a better visualization graph. Like the output here we have shown, it is our output screenshot actually. So this data we can predict from here and the better visualization for better understanding. When I after the completion of this output, I will explain about the what the map shows. Okay, now we take the confusion matrix 2 and n naught equal to true. No PLT, I want to enter the X label. X label, oh, wait, X label. From X label, I giving predicted. From Y label, I am giving to the X label was wait here X and Y, right? Okay, X is predicted and Y is for Y I am giving truth. Okay, it's truth value. Now see how beautifully the graph will be present here. See, like this we get the graph, right? So from this graph, so it is nothing but, so let us I will explain here only the screenshot. Okay, no. Here we have the predicted data and here we have the truth data. So from it, like we have the both decision. After the completion of decision making, final random set majority decisions, here we can see the middle values like 37, 39, 30, 36, 41, 39, and ones and zeros. Nothing, I will explain it about it. Here see the prediction value is 9 and truth value also 9. The order will be predicted clearly. So we can see the in x-axis and y-axis, the both number predictions is correct. So for that they get 28 and after that 8 prediction is for the 8 prediction is 29. Same y also truth also predicted 29. Okay. For 7, for prediction 7, it predicted 33. For truth value also 7 33. So for the row it match. For the row, you understand now? It is y-axis, it is y-axis, right? For the both predictions, it predict the same value, okay? If the prediction is correct by the truth and predict, okay? The value arranged in middle, at the same rows and in the joint of the uh, slope, okay? So, when the value get 1 means it is doesn't predict properly. For the 1, see, you can see 0 to 0 no prediction, 0 to 1 to 9 no prediction, 2 to 1 no prediction. Here we get 5 wrong prediction here. So here 1, see the 1. So 1 prediction is 8, nothing but is a wrong prediction. The 8 doesn't predict 1, okay? Here 8 prediction goes to 8, okay? Like this we get the graph. If the prediction of 1 means it is nothing but it's unpredicted, just mismatch, like the middle of the terms. It is like it is the friend ones and friend three. We explained previously, right? They are both are agree with the decisions. One is little bit agree and disagree with the right, obeying the obeisance. Like yes, you can buy it. Why you are wasting money? Like that. Some middle like that. Okay. For zero is nobody disagree with the statements. Okay. This is the graph which you are showing, and I hope you guys you understand about it. And thank you for this. Thank you all.